the ARM CPU allows you to do that, and you save one clock cycle.
So we do this just to reduce the clock cycle.
Yes, it's a more efficient way to access memory.
Oh, okay.
Yeah. All right.
Thank you.
Yeah. So another way to see is like if you do data processing in, let's say for example in Excel, right? There may be cases where you want to do repeated block of writing or reading, and sometimes you may want to skip things in between. That's like an analogy, and there's some keystrokes that you want to make in Excel to do that. Likewise, the same analogy, you can do this with a single keystroke. You may need to do this for those big data block processing. Okay. Any other questions? Okay, that's okay. Andre.
Yes, Prof.
You mentioned the recording has stopped. Has it resumed?
Yeah.
Okay.
Yeah. Thank you.
Okay, then I carry on with the next one. Post addressing, post index addressing. Okay, so this is what if you have this format R0, comma R bracket R1, comma the offset. So what the CPU will do is, okay, I'm going to read the location, memory location pointed out by R1, which is 05. Okay, compared to the previous one, let's look at the previous one. The previous one is they will actually pre-compute the offset, and then you read the memory location with the offset. For the post addressing, it does not do that. The post addressing will not read the memory address plus the offset. You will read the memory address pointed by R1 in this case, and then after you finish reading or accessing the memory address pointed by R1, it will then add the offset. You will then add the offset into R1. You will then, in other words, you will update R1 with the new memory address. So it's called post. So you read the data first, in this case, and then you update your it's called the address register. And this is the syntax to do that. You can actually do this also for LDR. This one very, very important. Okay. And this is another way for you to access data in blocks of memory. Any questions so far? I cannot see your facial expression, so the only way you can tell me your loss is the voice out. Okay, then if there's nothing, no question, I'll carry on from here. Okay, so this is just a summary. Okay, this is just a summary of what I mentioned for the past 10 minutes. So just an example. Okay, pre-index access with offset, but no update. Okay, pre-index access with update to the source register. Post-index addressing, and then followed by update to the source register. So you may need to go through the slides by yourself another time in your own free time to see the difference. But these are the three different flavors of accessing the memory using the load store command. Okay. like I said, this is like a fundamental thing that you need to remember, and you may actually use it in your coding. Okay, the rest of the instructions that you see right now, I flash before you. You can study this and use it by yourself, right? So some of you may ask me, sir, do I need to remember some of these commands? I would say yes and no. Why do I say yes? Because some of these commands are quite so-called self-explanatory, except like for all the or and EOR, right? So these are commands, just three-letter wording that you can actually remember in your mind. And then you just need to know, for example, N, right? Then I have a destination register, operand 1, operand 2. So these are like things that should be able to come naturally to you. So in this case, you don't really have to, in a way, it's self-explanatory. You don't really have to memorize how it's been, how this three syllable instruction has been formed. They are quite straightforward, I would say, except for the conditional commands. Okay, so yes, you need to memorize, but it's not that difficult. No is if the instruction is very rare. It's very rare, then I'll give it to you in exam. All right. Okay. One of the classmates asked, is there a class quiz this week? Yes, there's a class quiz, but it's in the form of assignment. So the assignment 4 has been uploaded in Moodle. You print it out, you write on it on paper, and to me by Friday 6 o'clock, 6 p.m. Similar as what you have done for the assignment 3. All right. Okay, next one. Okay, so for by now, I hope all of you, after you've gone through the review session with me, and also by now, you already should be familiar with these 4 letters, right? So these are status registers that you may actually program when you do the update. So N stands for negative, Z for 0, C for carry, and V for overflow, right? So V is called for overflow. That's where the V comes from. So you need to check, especially for your add, your sub, or your sub S. Okay? These are the ones that, if there's no letter S behind the instructions, the PSR don't get updated. So be very careful. Yes. All right. There are 2 more instructions that you will need to know. Okay, compare. So what does compare actually do? When you do a compare, let's say compare register 0 and register 1, what the CPU will do is that internally it will do this, but it will not store the result in R0. What it does is it will just update the PSR, the program status register. All right, so when you do compare, your R0 is not updated. And this is very useful for doing loops. Okay, you can do the reverse. So there's this called the reverse compare. Okay, some of these words are quite, I would say, very well abbreviated. So you should come naturally to you, right? So in this case, instead of the minus, it just does the addition. It's like a reverse compare. Okay, so this is for the math part of it. So the arithmetic compare. The other one actually is seldomly used, okay, which is the test. So it's the logical, remember the and or commands. So we actually do the and. So test R0, R1. It does a logical and between these 2 registers, right? And then you will raise the flag, whether is it a 0 or not. This is for more for bitwise comparison. And the other one is the test equal. Basically, that's the XOR. XOR. Remember the XOR truth table? So A, B, Y. So only when they are different, then the test condition is true. All right. This is what it's testing for, but it does not update the register. So please be aware of that. Okay. Yeah. So actually, we come to the end of the lecture. And one of the things that you have to do is to actually do more programming in the lab, right? And that's where you learn. It's very, I would say it's near impossible for me to teach you every instruction and what it means. So for this course is for me to introduce to you what are the possibilities of the instructions, and the rest is actually very much on you to actually read the manual and use the lab. I think I would say if you're able to do a lab confidently by yourself, you have no problem with the exam. You will have no problem with the exam. Okay, just a moment. Okay, so one of your classmates, before I let you go, one of you let you go, ask, so am I right to say that for post index addressing, do you mean the RD is not updated after Rn plus N? How come? Can you unmute your mic and we can let the whole class hear it? It's better.
Yeah, sir. So referring to the load memory at Rn to Rd, then Rn equals to Rn plus N. So after the Rn plus N, does it load back to Rd?
RD. So you will first load the address. Let's say your Rn refers to a address, say 0x, say 300, right? So your Rn will be, let's say, at 0x300. So suppose your Rn at 0x300 stores a value, say ABC or AB, for example. You will first load AB into RD. You first load it first, all right? And then you will update. Let's say if your N is, let's say, hex, if hash 10. So Rn in this case, after AB is loaded into RD, Rn will be 0x300A, because A is 10. It's a representation of 10. Does that answer your query?
So at the end of the day, Rd and Rn will have a different value, right?
Yes, they will be different value. They are not expected to be the same value. I mean,
Okay, thank you, sir.
yeah. Okay,
Okay, thank you, sir.
no problem. Okay. For store. Okay, so Kyrie asked a question. Kyrie, can you unmute your mic? So for store, oh, your house is noisy. Okay. The question is for store R0. Maybe I just write here. Just bear with me in my handwriting. Let me find a white space. Okay. So the class may overrun for a while. All right. So for store R0, R1, 12. Why is it the same as LDR? I don't get the question. So Kyrie. So let's look at this first. All right. So this is the destination register. So whatever the memory location computed here, the data will be loaded into here. All right. For the store, is the reverse. Wherever the data is here, is stored in R0, it will be stored in the memory location that is pointed by this location here. Kyrie, did I answer your question? Okay. Let me see, got other questions before I release the class. All right. So in a few more minutes, I will release the class. So remember, if you're not clear about the concepts here, you can go through with me later via email or MS Teams. And remember, there's a review class for you tomorrow afternoon, 1 to 5 p.m. Take turns, okay? Okay, Wei Xuan. Okay, the rest of the class can go. Okay, those who want to stay can stay behind. So I see the rest on Wednesday in person. Okay. Wei Xuan, can you unmute your phone? Your mic?
Hello.
Yes.
Okay, so like if you use the hang on, if you use the pre-index addressing, right? Then you use the exclamation mark, so it will save back the address value into R1.
Yes.
Like the updated address. So if you loop through this, then you just keep saving the value into the updated address value plus 12 plus 12 plus 12 each time.
Yes, exactly. Yes.
So that's what the function is for, like, is for you to like.
Yes.
Oh, okay, I understand now. Okay, thank you very much.
Okay. Okay. Kyrie, just a moment. I'm actually using two screens, my phone and the laptop. Okay. Sir, can I go to the slide and show? Cause the slide says R0. Okay. Which slide are you referring to? Is it this one, Kyrie? This one exactly, yeah. This one, Let me clear the ink. Okay. So what did Kyrie say? Okay. If you use exclamation mark, no wait. For R0, this is R0. Okay. Why is it same as LDR? No, because R0, like the destination. So this is your source in this case, and the source is storing 05, 0x5, the source. Then it stores this number because it's a store command. It will take this data in the register and then store it